And we're back. Module number 6 for the day. I believe I got it right this time.
Not for the day, for the course.
For the course.
Yeah.
I still got it wrong. So before we get started, I want to address a quick question that came up in the QA. Someone asked very explicitly, could they get a hand on our slides? Have a look down. We accommodated, and that person is now, that request is taken care of. That person has a hand on our slides. We're good. We're covered. Back to you.
I don't know what to say. Sorry. Doesn't get much lower than that, I'm afraid, folks. So, I'm Matt McSpirit, still technical evangelist, still currently employed. Corey, I'm not so sure.
No.
After that gag.
There you go. I'm Corey Hines. I'm the technical architect for Learn On Demand Systems. We're a training and hosting company. And we're back with Windows Server containers. I'm excited. I have been waiting for this module for at least 30 seconds.
Excellent. Yes. Well, in the previous module, we talked about Nano Server as a future direction for deploying your Hyper-V host, your fabric, your storage nodes, your network components, and your guest operating systems that can run your applications and workloads. And one of those workloads that can fit very nicely on Nano Server and is an ideal usage for Nano Server is containers. And in this module, we're going to go through just what containers are, what they can do, some of the use cases. Got a few demos of creating, spinning up, shutting down containers, and so on. And hopefully, if the demo gods are with me, as much as they were with you yesterday, we should see some pretty good container stuff happening.
I'm excited to see it.
I'm excited to deliver it, although it is a lot of PowerShell. But I've got a lot of copy and paste to save us a bit of time and effort. Otherwise, I'll be typing for quite a long time. So, what are we going to cover specifically in this module? Well, getting started with containers. What are they? What do they do? What can they provide? How do we deploy them? How can you get started in the most efficient and streamlined way using infrastructure that you've perhaps got today in your environment? So we'll talk a bit about that.
So to that point, if you're coming in from the DevOps world quite heavily, the concept of containers has been kind of in that world for a little while now, probably a year or so. Containers as a technology goes back really, really long way. It's become mainstream in the last year or so with the popularity of Docker. But it's
Linux containers.
It's very, very popular in the developer world, the DevOps world. For the IT pro world, as a tool to deploy workloads, this is sort of a new concept. So it's something new you've kind of got to wrap your head around. If you're thinking of, I used to deploy workloads in virtual machines, and now I can do them in containers and what?
Potentially,
right?
Yeah.
So this is a new thing for those of you that are coming from a traditional virtualization world. If you're a developer, this is probably something you're familiar with. Now we start looking at how we implement this on Windows Server. So.
Yeah, and containers is just another type of virtualization. It's another tool in your toolbox. It is an OS virtualization rather than a complete hardware virtualization that you use when you create virtual machines. So it's subtly different. It provides different benefits, different pros and cons. But it opens up new doors in terms of providing an infrastructure for your developers to really accelerate an agile development environment. And that's where we'll spend most of our time focusing on that, getting started and help you understand some of those use cases. We'll talk about integrating with Docker, which is a fantastic tool set that sits around containers and enables a more streamlined deployment, management, packaging of containers, all sorts of stuff we'll talk about there. We'll talk about development with containers. So just give you an idea of the dev lifecycle of how they can use containers more effectively. We're not going to necessarily do any development with containers, apart from the basics I'll introduce in demo. And then we'll talk about the different types of container runtimes that we have, because as indicated on the intro slide, there's Windows Server containers, and there are Hyper-V containers as well. So we have to think about both of those two types and what they are, how they differ, what use cases they can satisfy.
And so what a developer is going to do is they're going to build an app in a container. They're going to come to you and say, deploy this. And you're going to make the decision, do I deploy this as a Windows Server container or a Hyper-V container?
Yep, potentially. Or the developer might make that decision for themselves, depending on what you've given them in terms of the platform for them to use. So getting started with containers, let's plow on and let's start to understand just what some of these key components provide. So what is it fundamentally? A new approach to build, ship, deploy, and instantiate applications. Now, if we think about traditional data centers way back when Corey was a little bit younger, data centers, I need a new app in the data center. OK, I need a new physical machine for that.
When I was younger, they didn't have data centers. They had closets in the back of the office that had servers in there.
OK.
I did literally, at one point in my life, This was way back in NetWare 2 server.
Right.
That had been in a closet so long that they remodeled the office and drywalled the closet closed, and we had to trace the cable and punch out the drywall to find this thing sitting in this what once was a closet, still running. So that's
there you go.
Yeah.
But those applications, when organizations like that in those kind of, let's say, data center environments needed a new app, it was typically deployed onto a different physical system because of the isolation that app may have required. And when you think about that, that's how server sprawl really started. I need a new app, I need a new server. Even though the utilization may have been very low, we may have needed additional servers for load balancing or redundancy. All of those factors made server sprawl a reality for a lot of organizations. But then fast forward to virtual machines, which many of you, if not all of you, will be familiar with, and we saw significant consolidation benefits. Even just getting 2 virtual machines on a single host was a significant saving. But now we're seeing consolidation ratios of 10, 20, 30, even more to 1. What's your consolidation ratio in your lab systems environment, approximately?
I'm sorry, I wasn't listening. Yeah. I was answering a question in the chat line.
Right.
Well, what was your question?
On the chat line. What is your consolidation ratio in your data centers, approximately?
To how many VMs per physical host?
VM to host, yeah.
Hosts are about 512 gigs of RAM. VMs average 3 to 4 gigs of RAM. So do math on that. Probably about 100 maybe.
100 to 1.
100 to 1.
Okay. So again, great consolidation. And the key thing there is developers, application owners could deploy their applications now inside virtual machines in the same way they would have done physical. So there's still that application compatibility that was there. But they benefit now from, or the IT admin benefits from the ability to move that workload around because it's just a virtual machine. They can fail it over in the event of hardware outage. There was lots of new scenarios that opened up by packaging an application inside a virtual machine, which is great. But then containers puts a completely different spin on things. So we're saying now, okay, whether this system here is physical or virtual, it's just an OS. And we are using capabilities within the operating system, container engine, an OS virtualization layer, if you will, that's very different from the Hyper-V virtualization layer that we're used to slice the operating system into these containers and provide essentially namespace virtualization. So each of these containers thinks it's got its access to the nice, clean underlying operating system, and it can make its changes and so on off to a separate isolated partition that's exclusive for its use. So you're utilizing these containers that are fast to boot, they're incredibly quick to spin up and also destroy, so scale up, scale down. And it really does streamline how quickly application developers can deploy new instances of their workloads. In addition, you can run a lot of containers on a particular container host. Now, I use the term container host as a reference to the description of that operating system that's there with the words physical or virtual underneath it. Whether it's a physical machine running Windows Server, whether it's a virtual machine running Windows Server, that machine is what's known as the container host. And on that, you spin up containers, which contain your applications. And we'll go through this, and this will become more clear as we start to demonstrate and build out.
Someone had a somewhat interesting question. They said, this container, it sounds like Surface Host.exe, which is just a container for processes.
In some ways, yeah. I mean, you could encapsulate. It's similar to the way we encapsulate processes and isolate them. So yeah, fundamentally. But now
a container is a much higher degree of isolation, however.
Potentially, yeah. I mean, it could. The thing about a container is it could contain multiple processes. It could contain a single process or application. So you've got flexibility to package your app across individual containers or across multiple containers. But either way, you're isolating them from the operating system, and you're providing an ability now, so if I package my web app in container A, and I know that container A requires container host Windows Server 2016, I can move that container A to any Windows Server 2016 container host OS. So I've got flexibility for my developers to say, build once, package my application in your container, and no matter where I send it, whether it's Azure, whether it's to your data center, all it needs is that standard Windows Server 2016.
Absolutely.
And the same applies to Linux, and that's why it's so successful. And Linux distributions typically come from the same kernel, and therefore you've got flexibility whether it's going to an Ubuntu machine, whether it's going to a Red Hat machine, and so on.
And that's again, they come from the same kernel, but they can be very different.
Containers can be very different, but they're different, and their uniqueness is within the container. So it's just that extra bit on top of the base image. And we'll go through the whole images and how they relate to previous. It's kind of like differencing disks in Hyper-V. And you've got your base, and then you've got
layers and layers.
Layers and layers and layers. So one difference in disk might be a certain app that you've installed.
There's a dependency chain.
Yes.
And if you want the topmost, you have to have all the ones that chain down. Otherwise, the top doesn't have its dependencies. And likewise, if you break something in the middle of the chain, everything above it breaks as well. So there's this same notion of chaining with these images as there is for chaining, snapshots or checkpoints or VHDs, differencing VHDs. So for those of you that are Hyper-V admins or traditional data center admins, there's a conceptual comparison you can draw there.
Exactly. And if we think about why containers are becoming more and more important, it's really helping to unify the development ecosystem, the developer ecosystem, and IT operations. And it's still early days for a lot of organizations in this DevOps journey, but we're trying to help organizations really integrate better so that IT operations can provide a more streamlined experience and environment for developers to make their best work and deploy their applications faster without friction. If we think about how the developers benefit from containers, it really does, as the example I gave before, enable a write once. So I build my application, I package it in a container, whether that's using the Windows PowerShell-based tools or tools like Docker, and then I deploy it anywhere. Because I know that if I'm deploying to that container host in Azure, it's the same container host, essentially Windows Server 2016, as I've got on premises or as I've got in your cloud, for instance. So developers gain this new agility and flexibility without needing to worry about the underlying fabric. It can be deployed as a multi-tier distributed app. So if I've got an application that I know needs a database backend, an application middle tier, and a web front end or multiple web front ends, I can deploy each of those as individual containers, or I can package it as a single container. I've got flexibility in my development and how I package that application. And in addition, if I do distribute it out, it means I can scale each tier and update and modify each tier independently. So I've got, again, a lot of flexibility by separating those out. And some people talk about this concept of microservices and these independent services that make up applications and creating containers that reflect those individual microservices. And it's one way that can be used. They're not exclusive. You don't have to take that approach. You can combine and make your containers bigger versus splitting things out into individual layers. But it's all about how your developer wants to build. You've got the flexibility either way.
Question that's come up now about, I would say 15 times.
Okay.
Containers, server app V.
They are very different, but I can see on paper, and I could see if you think about that, what they're doing. They are providing...
There's a conceptual comparison you can draw, but the mechanics of implementation are extremely different.
Yeah, you're not streaming a container, for instance.
Exactly. But this notion of, here's a packaged runnable application, here, run it. And then they're version isolated. You can have multiple versions of the same application. Those types of benefits of things like server app V and app V, you get those benefits with container solutions as well.
Yeah, but the actual mechanism for packaging, the mechanism for running, the engine of running is very different from app V. And hopefully that will come through as we get later into the presentation.
Certainly I can see why you would make that leap or make that comparison.
Yeah. And then when we think about IT operations, what benefit does it give? What benefit does containers give, and what you have to be aware of? Well, once you've been through the demo and once you've seen containers in action, you'll see that it's actually quite similar to the way you manage environments today. Essentially, each container it thinks at least, it's an OS of its own. It's got its own IP address, you can connect to it, you can run PowerShell against it, and so on. So in essence, it's just like managing another machine. But for your benefit to give to developers, you're providing that standardized environment for dev, for Q&A, for production. And it means that you've abstracted away a lot of the differences in the underlying fabric, because the application owner, the developer, doesn't necessarily care. So you've got that benefit of real abstraction and streamlined development. On the upside, again, for you and your resources that you've got in the data center available to you, running containers will help you realize greater levels of density and usage utilization for your physical and your virtual container hosts versus just virtual machines alone. And I'm not saying you would use one over the other exclusively. You're not going to go all in for containers or all in for virtual machines. You may use a mix, but it's another tool in your toolbox to really help you benefit. And you can see on a similar sized host, you will see greater density for containers and more rapid spin-up time and so on versus the same virtual machine-based environment. And bringing those two groups of individuals together, so operations and developers, that's where we bring in DevOps. And it is about integrating the people, the process, the tools for an optimized app development process. So if you think, okay, today you might be an organization who has no developers. Is containers going to be the technology that sets your world on fire? Possibly not, because it's not really aimed at encapsulating the more traditional applications that you may have in your environment, like your Exchange servers, your SharePoints, and so on. That's not to say that it couldn't be done in the future, and it may be able to be done today, but that's not necessarily what it's aimed at. But if you've got a heavy development environment where you've got developers building applications and they're rapidly churning out new versions and they need a standardized environment, you don't want to stand in the way of that. You want to enable it and be seen as a hero in that environment. Then
hero, not a zero.
A hero, not a zero. Containers can definitely help with that. So a little bit more depth into architecturally what a container looks like. Well, if you think about what a container is, the container is on its own is made up of a couple of building blocks. There's the container runtime, which is actually the execution of the container, and the container uses an image. And that image contains whatever's relevant to that application. It could be application files, libraries, whatever it may be, and it shares and pulls from a base image, which it uses, and we said those dependencies before.
So these images are tangible things you can move around, you can download, you can transfer, you can share,
yes,
etc.
Exactly, and we actually will provide, and I'll provide some links and stuff a bit later on, Microsoft is going to provide you with a specific, for this release, the Technical Preview 3, a specific container host image that's based on server core, that's ready to go, and you will then be able to spin up new containers for that, for your testing, for your experience, for your evaluation. Remember, it's only Technical Preview, so it's not a production-ready configuration. We just want you to kick the tires at this stage. But that container host image, it ships as a virtual hard disk. You boot it, in this case, in a get started, we'll show it on Hyper-V. And once it's booted as a server core VM, you then spin up containers inside there. It's got each container you create uses the base image, the server core image, as its starting point. And then when you add things to the container, like web server files or a new framework or whatever, that gets stored in the container runtime for the time being. And then you can commit that container runtime to a new image. So you're starting from base. Once you create the new container from base, you've got a running instance of it. You install some stuff, you configure some stuff, then you save that as a kind of image plus one, if you will. But it's a lot smaller because it relies on the base, but it's just got the unique changes you've made inside there. And when you spin up a new container from this image plus one, it's got the things you added before.
So it's literally like differencing disk chaining.
A little bit, yeah. I mean, I don't want people to just go away and think there are differencing disks being spun up in the background and all that kind of stuff.
Because there's not.
No, but the concept is there. You're taking an image, you're running something from the image, you're customizing it, and you're saving it to a new image. And then you might create a new image from that image,
and they
so on and so forth.
Dependencies down the tree.
Exactly.
And all that you have in the new image is the changes.
Yes,
so
exactly.
Base image, new image, make a bunch of changes. The rights are captured here, much like, I go back to the example of differencing just to help people relate, but captured then, that's a new image, rights are captured, and just work your way up. So in theory, as you go up, the image likely gets smaller because of a larger base. Or
potentially,
if you add a massive application, it likely gets very big.
Potentially, yeah. And when we think about some of these dependencies, each app in your environment will have its own dependencies, whether that's software, libraries, hardware, or whatever. And the container engine is abstracting a lot of that. It's lightweight. It's a lightweight OS virtualization mechanism that's isolating these dependencies and allowing you to construct these different layers. And again, more of that will come clear as we go forward. But it is a shared host operating system. So that container host I was referring to before, let's take a simple example. You've got a physical server, you've installed Windows Server 2016, configured it to be a container host. That host OS that's on that physical server is now going to be shared by every container you create. So they're all going to use that base image, but each container could be doing different things because each one is unique depending on how you've customized each one.
So you, for example, have to kind of compare contrast virtual machine versus.
Yeah, you could be the VM guy, I'll be the container guy.
Fair enough. I'm okay with that. So if I spin up a container on Windows Server 2016, all the container images running in that are effectively Windows Server 2016 images.
Yes.
I can't, for example, have a Windows Server 2012 R2 container on that same host.
No.
Right? Because it's sharing the same OS.
Correct. Yes.
If I did, that's where a virtual machine would solve the problem.
If you need to run 15 different operating systems on a physical host.
Containers are not for you.
No. Certainly not in technical.
If you need to run 15 versions of an app on the same OS without needing to duplicate the operating system every single time, then containers become a great solution.
Yeah, correct. They're flexible because those differences in the underlying OS and infrastructure, yeah, that's all abstracted away. The container just uses that same base OS, and the containers spin from there. And they are rapid. And we'll see how quick it is to spin up a new container. Remember, each container thinks, oh, I'm a new container. I've got this whole Windows OS to myself. I've got
and incidentally,
namespace.
it's already booted.
Exactly, because the container host has got that OS there, and you're just essentially got the new
So
stuff.
you're defining a container. You're not booting it.
So when we think about how they differ from virtual machines, you'll see that when you create a VM, you create the hardware isolated virtual machine, you install an operating system in there, and it might be 10 gig in size. And if you need another, typically in production environments, you would create another virtual machine, install an operating system, and it'd be another 10 gig in size, and another for every new virtual machine you need. I mean, yes, we talked about differencing disks. They're probably not utilized in production environments for key workloads. So it's likely that each virtual machine will have a 10 gig starting point or a 40 gig if you're using fixed disk or however big it may be. So you can see that what a virtual machine does have within it is a lot more than just versus the container where you've got the base OS image and then these additions that might be very, very minor.
There's a lot of duplication that's involved.
Yeah. And you think about containers, and that duplication is essentially you're deduplicating a lot of that because you're using that shared OS. Whereas VMs, you have that independent operating system. Each one is isolated from one another, but you gain differences.
Here's another loose analogy.
It's a great term.
Deduplication for running operating systems.
In a way, in a roundabout way, yeah. We could trademark that. But you think about how you can use virtual machines today. I don't know what you're doing there.
It's a TM.
Oh, right.
TM.
Okay. Right. Excellent.
I didn't really do the M that well.
No, I don't know what you're doing. Virtual machines, if you've got a Hyper-V cluster or a cluster of virtualization hosts, you can move virtual machines around through live migration. So I'll pick up this Windows Server 2008 VM, shift it over to that host, pick up this 2012 VM, shift it to that host, Linux, yeah, I'll shift it to that physical host. With containers, you can't live migrate a container. It's as quick just to spin up a new one on another host.
So that brings up kind of a really interesting sort of discussion point on this. So for that, there was a question: does each container have a unique IP?
It can, yes.
It certainly can. So if you can't live migrate containers, this means that if you're designing applications to run in container environments, you really need to design them such that they're stateless.
Correct.
So that
ideally, yeah.
So that there's nothing of value in the application other than the logic. So that if you need to evacuate the host, there's nothing to evacuate except the logic. So all you need to do is spin up a new one, and the logic's now active.
And
so
we're talking seconds to spin up a new one. Boom.
So we're talking about this idea of fully stateless applications. The state, the stuff we want to preserve, is stored outside the container. The container is processing the logic, and it's quicker to spin up a new one versus try and move something over.
Yeah, that's right. And there's nothing to stop you running containers inside virtual machines that could be live migrated. So you can get about it a roundabout way, but we're starting to mix the areas there.
And there are technologies in the container ecosystem to do distributed containers, to actually manage this notion of having an application in a container, but having multiple copies of the
placing
container,
it all over the place.
Placing it and distributing it so that if a container does go down, there's other containers that will happily take over that workload.
Correct, yeah. And we think about one of the big benefits of virtualization, though, above and beyond containers, is the stringent and strict level of hardware isolation that a virtual machine provides. So when you create a VM, from a security perspective, and we touched on security yesterday in quite a lot of depth with the new shielded VMs, but that to one side, VMs inherently, through hardware, have a lot of isolation from other VMs on that box and from the host operating system. Whereas containers, at least Windows Server containers that we're talking about first, they share the host OS. So the same level of isolation can't be applied in a container environment, a Windows Server container environment, or a Linux container environment compared with virtual machines.
Patching the host patches the container at the same time?
You'd have to think about that, yeah, because you would patch if you patch the base image, then the container that relies on the base image you'd probably create a new image from that. But yeah, I mean, but the thing is about the images, we will provide the images.
Yep.
Microsoft will provide the Windows Server base images.
Okay.
So the ecosystem. Ecosystem is probably the wrong term here. I don't know why I use this term, but the building blocks, the key components. You've got the thing that runs. So when I say I want to spin up a new container, this is what runs, a container and its runtime. It uses an image, and those images are stored somewhere. in a repository. Could be local to your organization, could pull down from the web, it could be a centralized place, it could be a Docker hub. We'll touch more on that later on. But essentially what you're doing when you say, I want to run a new container, the container needs an image as the base of that runtime. So let's use our example where we've got our container host OS. Its base image is Windows Server Core. We say new container from that image, go, and it spins it up. And we've got a running instance of that base image. We then say, I want another container from Windows Server Core. Boom, starts up straight away. Another, and we can just spin them up incredibly quickly. If then we make a change to that first container and we say, you know what, I'm going to create an ipconfig file here, a text document, and store it on C drive. I can do that in local text, boom, save, and it's saved to that container, and I can then save and convert that container runtime to a new image that I store in my repository. And that image could then be used for future deployments of new containers. And the only difference from spinning up an image from the base versus spinning up a container from the base image versus spinning up a container from the one I've just created is that it'll have that ipconfig text file on the C drive, Absolutely. And that's it. As an example, I mean, it's a very crude example, but it's actually one we'll use in the demo to illustrate.
You know, bear in mind that containers is a lot of the questions that sort of flown through. People are thinking about containers like they're virtual machines. They're not virtual machines.
Yeah.
Right. This is a new way of thinking about deploying applications. It's a new way of thinking about managing applications and developing applications. It is not a virtual machine. You can't apply the same logic on how you manage, live migrate, design, cluster to containers that you apply to virtual machines. So you need to kind of shove that out the side for a second and treat this as something that's new.
Yeah. So you'll see in the image repository on the graphic here, you've got the Windows base image on the right-hand side in the repository. Then you've got perhaps a container that contains these application frameworks, and you've got containers that contain applications, and they combine at runtime to enable you to provide an application or service to the business. So it's all about layering those images and combining those in such a way that the container at runtime provides the functionality that's required. And you can have multiple containers providing the overall application. So like I said before, you could have a web tier that's all the web servers are from containers. The middle tier where the application tier and all the logic is held, that's a different set of containers, maybe more than one for redundancy. And then you've got your database tier, which again could have multiple containers providing that. You would obviously have to factor in the load balancing and how those all communicate and are controlled, but fundamentally you can break apart and abstract those different components of an application and split them across multiple containers. So to explore that in a bit more depth, I've got my nice graphic here. Don't be confused, this isn't like a VCR from the 80s. This is a really stretched graphic of some kind of physical system.
It kind of looks like a home theater receiver.
A little bit, yeah, with a screen, you know, volume up and all that. So that's our physical host, believe it or not. So just, I know, my graphical skills have let me down here. We install an operating system, and we deploy our images. And that's essentially a simple example. That's where today, if you think about physical host, OS, applications, that would be our image. When we think about the next step and compare that with virtualization, we enable Hyper-V. Our host operating system becomes this privileged parent partition. And from there, we create virtual machines.
That contain hardware, virtual hardware.
That are hardware virtualized, yes. And inside that, we install operating systems and applications. That's, again, a traditional virtualized environment. But then we think about containers in more depth, and we think, OK, I've installed my host OS on this physical system in this case.
Now, there is no hypervisor, I noticed.
No. And in this case, we can just enable containers. And it doesn't have to be running on a physical host, as I said. It just needs a container host OS that could be a physical server or a virtual machine. But inside there, we're using OS virtualization to slice up the resources and provide them to each and every container that's present on the system. You'll notice I've squeezed quite a few on there. And they all have their independent application or their linked applications, whatever it may be, with their own dependencies. But all of those, in this case, how many have we got? 1, 2, 3, 4, 5, 6, 7, 8, are sharing the resources of the host operating system. But they only may differ from one another by just the changes that you've deployed in that particular container. So the one on the far left might have an Nginx website, a web server. The one next to it might have a MySQL database. But they're all utilizing the same shared host OS. And that's the power of containers and the speed at which it can deploy. But there are other combinations you can make. So in this case, we've got a hardware virtualization layer, so we've enabled Hyper-V on the physical system, and the host OS has become the privileged partition. We can deploy containers, Windows Server containers on that machine, so on that host OS, even though there are actual virtual machines running on that same host OS as well. So imagine you've got a physical system, you've enabled Hyper-V, but you've not created any VMs.
So in this scenario here, I want to hit back one time.
Yep. Again?
Yeah, no, sorry, the other way.
Forward, you mean?
Forward, yes.
Right.
I thought you went
the opposite to back.
Yes, keep going, one more.
And again.
And there we go.
Right.
So in this scenario right here, host operating system, lower left, Windows Server 2016, now running a VM. Host operating system, maybe a different variation of Windows Server 2016 to give me a different base OS to base the containers on. This is sort of a valid scenario.
Your host operating system would still be your container host OS, yeah. So it could be Nano, it could be the server core, whichever one we ship and provide you with. So what we're saying there before we bring in the VMs is you've enabled the Hyper-V role. You're eventually going to run VMs on this system as well. And I'm not saying this is a common scenario where you mix and match, but you may do. In this case, on the host OS, on the parent partition, you've said, OK, new containers, boom, 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 and you've created 5 in this case. And they're sharing the host partition. But you've said, OK, you could also create a VM using the traditional Hyper-V mechanisms. And in there, you install the same base host container OS. And inside there, you run Windows Server containers. So it's just illustrating the flexibility you can have about where you run these things. Not necessarily that you would do this specific configuration. You may choose that a physical system runs Hyper-V VMs, and you run all your container host OSs inside the virtual machine. It's up to you. You've got flexibility. So let's have a look at a brief demo. Let me pop out of there.
So while you're getting in there, the Q&A is just blowing up.
I can imagine.
As you can imagine, it's absolutely just blowing up.
Uh-oh.
And I want to kind of sort of mention a few things. So to kind of help calm down some of the almost panicked questions. Number one, virtual machines and containers are different. Don't apply your logic of virtual machines and containers. Number two, this is only just getting announced with Microsoft. This is a new thing for Windows. It's a new thing for Microsoft. You can be assured that documentation, guidance, dedicated sessions, and everything you ever want to know about containers is going to be coming out very soon and in great detail. So a lot of the questions that are, quite frankly, very complex to answer, like automation, orchestration, resource control, patching, all these operational tasks that the IT administrator is thinking about. It's like, how do I manage this? How do I deploy this? How do I keep this from? How do I scan it? How do I? That information is coming. We could spend 3 days on containers alone to cover the plethora of topics that relate to them. So for now, our goal, let's get the concept of containers across, let's kind of understand what their role is, how they work, and then the mechanics of management, all those details is going to be forthcoming through documentation, through MVA sessions and everything in the future. So just calm down.
Yeah, there is actually some documentation that's already been published on MSDN, so we'll fire up the link a bit later on when I've checked that it is actually live. But in terms of demonstration and getting started, what's the easiest way for you to just kick the tires on containers? Well, for me, the easiest way is for me to go to my Hyper-V host, to run a couple of PowerShell scripts that will go and grab the container host image that I've been talking about, the one that Microsoft will supply, run another script that creates me a virtual machine from that image, and then I can start playing. And the documentation that was published, again, we'll provide you the link a bit later, actually talk you through that. But I'll walk you through it as well, just so you can see. So what we have on the screen here is a very simple, let me make this a bit bigger so you can see it. Is that better, Danny, do you think? Yeah? That looks good. Good. So you'll see that we're going to use this particular command to grab from the web a script, and that script is going to be saved locally on your system under this new container host.ps1. And if we look, just get stored here, new container host ps1. And it's when you open it up, there's quite a lot of information in there. But essentially what that's going to do is when you run it, and I'll run it here, new container host ps1, VM name, container jumpstart 003, and then a password. If I run that and kick that off, I'll go read the EULA. So it's saying, yeah, you should go and read this. We use a lot of aka.ms links nowadays. I'll go yes. Now, that flicked through very, very quickly. But what it said initially was, you've already got this virtual hard disk that I would otherwise pull down from Microsoft on your machine here.
So step one is pull a big old VHD up.
It does it for you. It will go and grab that from a specific location. It will go and grab that It's actually a zip file. It will extract that as a VHD and place it in your default Hyper-V path, which you've configured in Hyper-V settings. You'll see mine is Hyper-V/VHD. This is, as you'll see, Container Jumpstart 003 is the third one that I've run. And by that, I've already got the virtual hard disk downloaded and extracted in the right folder. So it says, OK, it's already present on this system. I'll use that and create a copy and go from there. So you'll see it's doing a few things. This script, I've not written this. I can't take any credit. The guys in the Hyper-V and the containers team have written this. But this is essentially just helping you quickly set up and kick the tires with containers.
You're not taking credit nor blame.
I'm not yes, exactly. So if it doesn't work for you, those pesky Hyper-V containers guys, it works great. They are. Those Hyper-V and containers guys, they are great. But you'll see what it's doing now. So right in unattended XML, copying the install container host PS1 into the virtual hard disk. It's just within 5 minutes or so, this will all be done. And all I will have left, if I go to my Hyper-V manager, the VM hasn't started spinning up yet, but all I'll be left with is whatever I called the VM here. Oh, there it is. Perfect timing. They will start it up. They will do the customization. All of what I will have left to do is run one additional command that will join it to the network. So I've got to have a vSwitch already configured on my Hyper-V host to allow, if you want to give it internet access, it's up to you, and that will join it.
So what this is doing is giving me a VM that has the container bits.
The container host OS ready to go.
Ready to go.
Yes.
Okay. And then I can go in that VM and play with containers.
Correct.
Okay.
Yeah. So that's how you would get started in terms of downloading. Now we are going to provide one on Azure as well. So if you've got an Azure subscription, you could just go to Azure, and the Azure portal, and deploy from there.
So this is a normal VM that it's building for me. I can export, migrate, whatever. It's just a VM.
Correct.
But it's a container image VM.
Yeah, I mean, if you look here, these just look. This is Hyper-V Manager. There's nothing different here. These VMs just look and feel like regular VMs, but inside there is a server core image that's got the relevant container stuff ready to go. And it just saves you you would be able to set that up manually if you wanted to from the 2016 image, a server core image. But this is so much easier if you just want to kick the tires. So let's have a look how far away. Specialization to complete. It's booted. Yep. Configuration's good to go. So like I say, you would just finish running that, and that would be complete. And that's essentially, in my terms, that is the easiest way to get started with running a container. Just getting it going. Obviously, it's not doing anything at this point. It's not providing any functional services for us or anything. It's just there. So essentially, what I've showed you is how to spin up a VM, which we covered yesterday extensively.
Excellent. So
I'm a giver. I'm
glad you got it. And again, guys, on the Q&A, we will get to all of this stuff. There's what he's doing, how he's going to administer, how he's going to make a container. It's all coming. So just
don't worry.
Patience.
Calm down.
Yes.
So let's go back.
They're very excitable bunch this morning.
No, I'm excited to tell you. Don't worry. I'll get to it as quickly as I can. So image creation. So now that we've got our container host building in this case, remember when I say host, don't be in the mentality of host. He means physical host. He means Hyper-V host. Container host is an OS running Windows Server 2016 that will run containers. It could be inside a virtual machine. It could be on a physical server. It could be in a VMware VM. It could be in an Azure VM. You could run it anywhere you want. But the container host is where the containers run. The container runtimes run. So you'll see here, image creation. Let's just go through a little bit of workflow on how and what happens here. So we've got a local repository where our base image is stored. And in this case, it's our Windows Server image. And you'll see on the right-hand side, we've got this container view, and the container is currently off, like the one we just create or just in the process of creating. It's in an off position. However, when we spin it up, we say, OK, you've now got a sandbox. This container is now active, and it thinks it's got this beautiful, clean C drive / Windows OS that it can do whatever it wants. But remember, we've namespace isolated this container from the host OS, but it is sharing. It has a view of that underlying base image. So it thinks it's got its own, it can do what it likes. So it's currently empty. So what would we do in there? What would we do in a container? What would you like to do? Well, for me, I would like to install and add some packages. In this case, we'll add Node.js so that our developers...
I was going to play Doom.
You might be able to add the Doom bit, like a Doom container. Seems a bit depressing. Yeah, let's create a Doom container. You're strange. Anyway, we'll create this Node.js. We'll add this Node.js.
Says the guy with that accent.
It's got nothing to do with it. We'll add Node.js as a framework. So think about it. This container now, when I save this back, so I've got my Node.js now, so that container as a runtime contains Windows that it was sharing, any changes it's made through that Node.js framework that's been added, and it's still within its runtime. So what we would then do is we'd shut that container down, and we would convert that container to an image that we would save to our repository. So now we've got an image that essentially takes the base and layers on these changes. So that's, in essence, a really streamlined way of, if a developer now needs an environment that's got Node.js, they would simply select that container or that image called application framework and spin up a new container from that particular image. And it would reference the base image where required. So you'll see now, developer comes along and says, I need a new container to do blah. In this case, I know I need Node.js in there, so I'll select the application framework as my starting point for that container runtime. And now I've got essentially a fresh container where the starting point was the image we just previously created. And now I can add additional stuff, like I could add another framework, or I can add a text file, or whatever it may be inside that new container. So you'll see here, I'm going to add my application. I'm a developer, I'm adding my application into that particular running container. And so that container now contains a couple of extra bits. And we save that when we shut it down. We essentially create an image from that container with the app inside. So you'll see how we've created now 2 additional images to the base. And if anybody wants to deploy an instance of my app, they would deploy and that container would have the necessary information it needs.
It would grab the dependent containers with
exactly what it needs to run. So yeah, that's in essence how we create that image. And let's have a look at that in action and hopefully make this come to life a bit more. So we can see our image has finished creating, our virtual machine containing the container host. It's getting confusing when I say containing. That has within it a container host OS. And all we'd need to do is get VM, get network adapter, and enter the switch name. But I've got it there for you, but it's all well documented online as well. So what do I need to do? Well, I'm going to go into container jumpstart 001. This is exactly, all it's at this stage, it's at exactly the same stage as that previous one finished, but it's got a network adapter.
This is just server core.
It's Windows Server Core with the relevant container bits turned on.
As opposed to the irrelevant container bits turned on.
Yes.
Okay.
Excellent observation. Now, this PowerShell window I've opened as well. All I needed to do was log in as administrator, and to save us a lot of time, I've got this script, if you can call it that, where I'm going to just copy and paste some bits in, but I'm going to explain it on the way. So first one I'll use is get container image, and that is going to essentially say, okay, what container image do we have currently in the local repository? And you'll see it's the Windows Server Core. That's the one that we've loaded the container host OS. Is OS image? Yes.
And so the repository is part of that host OS container.
In this case, that is the local repository. But remember, you could have centralized repositories that you pull from as well.
So by building this container image, you automatically get a local repository, which is one image, which is the Windows Server Core container.
Yeah, the base, essentially. You've got to start from somewhere. Remember, containers share the base OS, so they can't share it from nowhere. There needs to be a base image. So we'll get the VM switch, and we'll see what networking this has got, and you'll see it's got NAT, and nothing more at this point. The name is virtual switch, and it's natting from the host. So let's create a container. You'll see I've got my PowerShell here. Let's hope this runs effectively. Oh no, I need to. That won't run in a command prompt, will it? So I need to come out of there. So let's do container equals. It's always handy if you type, and then we can see some of the red squiggles that. Oh, no, it won't show. Oh, it will show red squiggles, won't it? Because we're in PowerShell. Here we go. Container.
Does it make you feel good about yourself to point out my syntax errors?
I can't type properly. Container image name is Windows Server Core. So it's saying, okay, you want to create a new container called Jumpstart Container 001, JS Container 001, and you want to use as your reference point, the Windows Server Core base image, and you want to use switch name, and it's the only one that's on the switch. This assumes you want to connect it to the network. Virtual switch. There we go, and that should work. Boom, there we go. So if we get container, this is where you realize how bad a typer I am. So there we go, we have a container. It's off. Remember the graphics that we showed before? We've created a new container from the image. So let's start it up. container name JS container 001.
I think you're quite a good typist, quite frankly.
I'm not bad, but I do use one finger typing. I should really learn.
You're doing that with one finger typing.
Well, you know what I mean. I'm not using like proper expert typing like if I was, white papers take me a long time, put it that way. So we've started that container now. So we're going to enter the PS session. So I can do this one like.
Now, wait, it started already?
Yeah, it started, yeah. I mean, I can get container if you want.
Please, because I don't believe you.
Well, obviously we've left it a little bit now, but it's running 21 seconds, and I think our conversation was about 20 seconds.
22 seconds ago.
Yeah, something like that. Yeah, so it's pretty rapid. So let's enter.
But again, this is the notion of this isn't a virtual machine. This is a boundary.
It's a namespace isolated container that is
a full container. It's not I'm not booting an operating system. I'm just going, here's an isolated copy of the currently running operating system that I can now deploy in and make an image from.
But the key thing here, and you'll see that I've entered PS session, I'm now PS'd into the container. And you'll know because it's got this unique ID that's relatively meaningless in terms of you can't tell what it is. But if I do, let's pipe ipconfig into a text file. There we go.
Can we see what the IP config is there?
No. There you go, 172.16.0.2, so that's natted to the default gateway on that machine.
And that's a different IP than the actual host itself.
Yeah, the host is on a 10. Whatever
Perfect.
network, yeah. The host, the physical host, the Hyper-V VM has got, I don't know what the Hyper-V VM IP is. But you can see if we now read that up, so we can read contents of the file, even though remember this is in the container. There you go, same kind of information, so no different there. So let's exit that remote session. And now we'll stop the container. Boom, there we go, done. So, as I said before, an image, now that we've customized that container with some deep customization, remember we added an ipconfig text file, which is going to be relevant to everybody, we can now create a new image from that container. Remember that separation. The container is the runtime. The image is what you use to start the container as your starting point. So, we'll do new image, in this case. Let me just paste the command in there. New image equals new, it's running on a new container image. Container name, the one we just shut down. Publisher, in this case, I'm calling it demo. Name, JS image 001. So remember, we had an original container, a base image of Windows Server Core. Now we should have two images. So if I do the get container image.
The version number is important in here, is worth noting. Because as you deploy multiple copies of the same container, you can advance the version number. So it becomes very simple to say, grab, we deployed an application last night in a container, and we discovered something broke at 3 in the morning. Let's just go back to the previous version of that container.
Exactly, yeah.
So you can use that version number quite effectively.
You go back to the version of the image to spin up the new container.
Correct, yes.
Because there's no version associated with the container per se.
It's the version of the image.
It's the image that you start from.
But that version is an important point to keep.
Yes, absolutely. So if we look on the screen now, you'll see I've done get container image, and I've got two images. JS image 001 that I just created as from the base, and you'll see is OS image, and it's false. So what's next? We've created our new, so we'll deploy a new container from that customized image. So those of you that are following along, what should this container contain by default that the first one I created didn't?
An IP config file.
An IP config file that I heard from somewhere over there. Yes, that's correct, yes. There you go, new container, so that's a container created. So let's start it up. Container, 10%, there we go, boom. So get container. There we go, so 001 is off. Parent image was Windows Server Core. Container 2 is running. JS 001 was the parent image there. So again, we can enter the PS session into this new container, JS container 002. And that should let us in. And it should, by default, contain, so you notice a different ID. I can't remember what the previous one was, but it wasn't. Oh, it's there.
It wasn't that.
It's there. It started with a 3.
There you go.
Yep. In this case, there's the IP.
Well, that's the text file containing the IP.
Correct. That's not the right IP for this container, though. It shouldn't be, because it's the IP config text file.
Exactly. What is the IP of this container? Actually, I bet it's going to be the same. I think it's going to be the same.
Okay.
Because there's only one running, so it's grabbing the next available IP address in the NAT pool.
There you go. All
So
right,
if you were to have the other container running at the same time, this would have grabbed 3, but had the text file that contained 2.
That's not part of my script. I'm not
I realize that. But if you followed that logic, that's what would happen.
Right. So now, if I exit out of there, I'm going to on the container host. I'm now going to stop all the containers, even though there was one already stopped. I'm going to remove all the containers. So I'm going to clean up after myself. Oops. There we go. That's gone. I'm going to get the container image JS001. So I'm going to set us back to a clean slate, essentially, and just clean up all those images. So I've got the container image name JS image 001, remove it, and that's done. So now let's do something. If I get container now, we've got nothing. If I get container image, we've got the base. Okay, so we're back to fresh.
So there's a whole bunch of questions around the IP address stuff.
Yeah.
Well, the big one is, where'd the IP address come from? And the IP address came from the fact that on the container host,
Yes.
you defined a virtual switch.
That's using NAT.
They're using NAT.
Yeah,
so
no, you can use DHCP.
Sure, and it's handing NAT addresses in to those containers as they spin up. You could also use an external connection.
I'm sure you could, yeah.
Right? So you can actually get them off the physical LAN if you wanted to.
Yeah.
Maybe
So
those
this is
containers need inbound connection.
This is just using a simple NAT where the container host OS is natting through to the containers themselves. So they can get in and out via the container.
And so what you're seeing there, 1.9, is just the default IP scope the NAT switch for the container OS does.
And this is what's documented in the guidance that'll be on MSDN. And remember, it's just a getting started, just kick the tires. As we go forward and we publish more guidance and more information, that will focus on more of the customization and how you can use things like DHCP and existing DHCP, how you can set some more of the advanced configuration. So let's deploy a web server. Now, I know there was talk about does Nano contain IAS and all that kind of stuff. We're not going to use IAS specifically here. We're going to use, what are we going to use? We're going to use Nginx. So I'm going to create, which is an available web server package. So firstly, we're going to deploy a new container. We're going to call it web base. We're going to use the Windows Server core as the base image starting point, and we're going to connect it to virtual switch. So off we go there.
So now Windows Server Core, which is that base, now has a couple of containers going this way.
Well,
now
just one, because we cleaned everything else.
Yeah, just one, and then we got another container going this way.
Yeah, so now we're going to start container, and we're going to use container. So we're now essentially starting the container that will eventually become our web server. So we've started that up.
No, Matt will not be demonstrating a Doom container.
No.
You can stop asking.
Minecraft, maybe. Although it wouldn't run on core, I don't think. Although maybe, I don't know.
I don't see why not.
Yeah. Maybe as a Minecraft server that you can.
Can we do it with the HoloLens?
It's getting deep now. Let's just focus on the containers.
All right.
So if we enter PS session into the container, so from the host, container host, into the container, you'll see I'm now inside. Different ID to what we saw before, because this is a completely different container. And now, hopefully, if my web connectivity, which I should have tested actually in advance, and I haven't, so this may not work, but essentially what I'm going to try and do...
Everybody cross something.
Yeah, cross something if you can. If not, we go to video, because I should have tested this in advance. From inside the container, I'm going to request to download from the internet, from the World Wide Web, this Nginx file. So here we go. And store it on the C drive of the running container in that folder. And there you go, it worked.
Wow.
Yeah, it did it. So now if I extract...
Those Hyper-V and container guys are good.
They're not bad, actually, yeah. I mean, they've done a good job. So now, inside the container, I'm going to expand that zip file that I just downloaded to the C drive. Boom, 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 boom. That must have... Oh, there we go. It's going swimmingly. So we'll exit from the container. We'll stop it. And the reason we're stopping it is now we want to create a new base image from that container. Because essentially what we've done is we've spun up a new container from the base image. We've added some Nginx web server bits and stuff. We've shut the container back down now. We want to save those changes we made off to a new image that we can then use for future web server deployments. So let me customize this very quickly. I'm getting rid of those little dashes that I have. So we've no containers running currently. So if I do a get container, there's our web base currently off, so we can make an image from that. There you go, web server image, and store it as, use the container that's currently in the variable container, publish as demo. The name is going to be Nginx Windows because it contains the web server bits that we just downloaded. Go.
So while that's running, question that came in, is the file system I'm looking at in this container a copy of the file system, or it's so what it
Just thinks it's
Yeah.
it just thinks it's got access to the Windows file system.
Read-only view of the file system of the container host.
It doesn't know that though.
Of course not.
Yep.
When you write, the writes are captured in the image.
Yes. They're captured. They're held in the container until you then write them to the image. Yeah. Because because you could shut down and destroy that container.
And all the writes go away.
Yeah, and everything would have just disappeared. So, where are we up to now? So I've deployed the web server image. So let's have a look at get container image. There we go. So there it is, our Nginx Windows. So remember, the only difference between these two is, what's the difference, Corey, between these two images?
I was reading a question.
One's the base, and one's got the Nginx web server bits in.
Well done. Good answer. You're correct.
Yes, I know. Yes, excellent.
Here's a delivery tip. If I'm looking this way, don't fire a question at me.
I'll write it on the chat.
There you go. You'll get it.
Right, okay, so we've got our container image. So what are we going to do now? We're going to deploy a new container based on this Nginx Windows image. So we're going to go, here we go, virtual switch. So let's copy and paste this in. So web server container, new container, name web server 1, using the image Nginx Windows. Let me just scroll up to make this easier for reading, and attach it to the virtual switch.
The non-PowerShell guys are probably bleeding from their ears by now.
Well, I'm trying to step through it as easily as I can. It's better than...
You're doing a fantastic job.
Thank you.
See,
I wouldn't classify myself as a heavy PowerShell expert, you know, as you can probably tell.
Well, you've got copy-paste down pat.
Thank you. Right-clicking as well. So we've started the container, so let's do get container. Here it is, web server 1 running. Been running for 8.6580000 seconds. I always find it's handy to have that many.
To the 10 millionth of a
Yeah,
second.
just in case. So we'll PS session into that container. And we will start, once it's in, we'll start the Nginx. Let's navigate to the Nginx directory because it's there. We'll start. See, I typed the really easy ones. So now that is, hopefully, boom, there we go. So we exit, and we are, that container now, that the runtime of that container, what is actually running, is a web server.
You're very excited about the output of a command that has no output.
I get like that sometimes. So now we need to give it a static mapping so we can get from outside to in. I mean, this is just part of the demonstration.
So now what you're doing is basically you're punching a hole in the quote-unquote firewall to allow port 80 to go from the host into the container, just as you would do on any NAT device in any network.
Yeah.
And it's the nature of how this demo is set up makes this sort of necessary. If this container was set up to pull an IP address off the real network, you wouldn't need to punch this hole through the NAT device that the container OS is providing.
Yeah.
So it's done this way because of how the demo is set up. So.
Yeah. So if I now run this file, oh no, I've got those. I need to run this. Oh, that's a PowerShell. Hang on. So this is going to take me a little while. Let me just. Oh no. There we go.
So Michael just said goodnight on the chat. He's got to go attend to his wife and kids' his home container.
Very good.
I like that.
Yeah, that's good. Oops. Will this work if I just try? I should be using this I made this in the ISE, so it's probably not great copying and pasting it into the command prompt here, but hopefully. Bosh, there we go. Right. Now what I need to do is check what IP address I need to navigate to from the host, from outside, to get to this particular virtual machine, or this particular container. So let me just, so I need to open up a browser. So let's stop that for a second. And what IP address should we try? I want to make sure that, should I try this one, 172.16.02? Is that going that through? That's the internal, so I need to come to the Hyper-V VM IP address.
Have a look at Hyper-V Manager, go to the networking tab.
There we go, thank you.
And that should tell you down there.
Right, so that is my IP. So 10.120.228.113. I've already forgotten it. So let's go here. 10. No, it's gone off the screen there. 10.120.228.113. Here we go.
I think.
Let's just check it before I press enter. 10.120.228.
There you go.
Boom!
Oh, yeah.
There you go. Web server in a container. I've never been so impressed that that worked. We fist pumped there.
We did.
Yeah. Boom. There you go. So hopefully you fist pumped at home. Woo! Yeah, that's working. Containers actually work. It's great. That was how easy it was. And it only took us about 20 minutes of looking at PowerShell to do that. But that's the document.
You're acting very surprised this worked. I had faith. I knew it was.
The first time I ran it. I didn't test it before. So, yes.
Folks, this is live. And when we say live, we mean live.
Yes, there you go. So,
some of these things literally he only got last night. So.
And this morning, I was building these container VMs about an hour and a half before we started. So there you go. That is that one for that demo. So hopefully that gives you an idea of how we customize the image, we create it, we save it back. We did a load of stuff there, but hopefully you followed along. I mean, I went at a pace that hopefully most of you would be able to grasp if you've never seen it before and don't do a lot with PowerShell either. Now, obviously, you say, well, we used a lot of PowerShell there. PowerShell isn't the only tool you can use to start to integrate and administer and manage these solutions, and that's where Docker comes in as well. And we've got big integration and strategic investments and a partnership with Docker, who've been in the containers game for a lot longer than we have, working with the Linux community, building out more of an ecosystem around containers. Yeah. So what is...
And like the idea here is if you're going to come into an ecosystem that's sort of established, like the container ecosystem,
yeah,
and come in and go, we do this now, and here's all new stuff you've never used before.
Yep.
You're not going to get rapid adoption. So this partnership with Docker is about helping the developer community adopt this a whole lot quicker by using tools they're already familiar with.
Yeah, exactly. And what is Docker? Well, Docker is an open source engine that automates deployment of any application as a portable, self-sufficient container. So it helps us to package, run, deploy, manage those containers. And the beauty of the Docker solution is that it will give you a single management interface and a packaging and an experience across Windows Server containers and Linux containers as well. Regardless of the hosting environment, your cloud, my cloud, on-premises, you've got the flexibility there. And what you saw when we did the initial deployment of the container host OS, the first PowerShell script we ran to grab the image, deploy the VM, that actually injected and installed the relevant Docker components in the Docker engine that enables us to use Docker in there as well. So if we look a bit deeper, what makes up Docker? What are some of the key things that you need to be aware of? Well, you run your commands from the Docker client, and that's where you fire commands like docker run, Docker images. So like we were doing before with PowerShell.
So it's the same PowerShell commands you were just doing, but in Docker.
In a Docker world.
In Docker language.
In Docker language, yeah. So in essence, when I was running get container and get container image, this would be Docker images, would get me the Docker. And we'll see that in demo shortly. So Docker Hub, that is where, and this is publicly available, where you can download a load of different curated packaged applications that you can pull down into your environment. Some are very small and very specific, some are broader, and there are even applications that have been packaged on the Docker Hub that are from large vendors who have packaged their applications ready for you to download within and deploy quickly in containers. So the Docker Hub is a central place where you can pull down a lot of those packaged applications. As I said before, we're collaborating with Docker to enable centralized management across Windows Server, Linux, the Docker engine living on both of those. So Windows Server 2016 will support the Docker engine. It's not necessarily going to be backported any further because the container capabilities don't exist in any previous version of Windows Server. So the Docker engine for Windows Server containers will be developed under the Docker open source project, and Windows customers and Docker with the Docker client can use the same standard Docker client and interface across those multiple development environments. Now I was going to do a quick demo with Docker. Let me go. I'm going to turn this one off in case there is, although there shouldn't be a conflict because the VM has got a different IP. But so jumpstart number 002, if I go into that here we go. So do you want to do the same kind of thing again like we did before with the IP config? Should we just skip that?
We can skip that, yeah.
So but some of the different commands. So Docker images gives us the list of images. So if we do here, there you go. In our repository, we've got Windows Server Core. There's the latest. They are essentially the same image.
And you'll notice, I mean, this looks and feels kind of the same as the PowerShell commandlets.
Yeah.
But again, the folks that are already well and truly used to the Docker ecosystem, they know these commands. They don't got to go learn the PowerShell. They can use the scripts, everything they're comfortable with. but do it on Windows Server with containers.
Yeah, and one thing to note here as well is that this, you'll see on the view here, virtual size 9 point whatever gig. That's the server core base. If I create a new container and then save an image from that and create a new one, let's call it web server, it might be 9.7 gigabytes. That's not to say that individually it's consuming another 9.7 gig in the system. It's just the changes, it's reflecting the overall
the total size that's needed for this image, which includes it plus all the images it's dependent on.
Exactly. Now to create a new container with Docker, we simply do docker run instead of, I think, was it a new container with PowerShell? Well, the docker run is actually creating a new container as well.
Fair enough.
So you fell into that trap. And it was a good, I'd lured you in. The interactivity, we do...
Tricky.
Yeah, there you go. We'll call it Docker demo, Windows Server Core, and we're going to launch the command prompt as soon as we enable that. As soon as we create that container. So this container is going to be created, started up, and it's going to start the command prompt straight away from there. So that's creating the container. There we go. And you'll see I've put into that container. So there you go. We are actually in the container. And if I look here, so I'll do an IP config again, just to illustrate. We'll save it to a text file. So I'm inside the container here. We'll do type it again. I'm not sure what the IP address will be. It's the same because it's inside a different container host.
It's the first machine on the net range.
But on the different container host. Remember, we are on container host 2 versus container host 1. So let's exit out of there. And we are back at the container host. So let's go clean up the screen. And so to see a list of containers using Docker, we simply go docker ps-a. You'll see, although that's not rendered brilliantly, let's go scroll across. Names, there's Docker demo. Yet the command that was run, it was created 52 seconds ago. It was exited 9 seconds ago with no ports that are specific to this configuration yet. But you'll see some of the subtle differences as we go forward. Now to create an image from that particular Docker container that we just ran and exited, we'll do docker commit, docker demo. That's the name that we use for the container, and we'll create a new container image from it. And now what you'll see if I then run docker images, once that's completed, there you go, taking a few seconds. Come on, come on, come on. He's thinking about it. It's thinking. Let's just scroll through some. Oh, there we go. See, as soon as I threatened it with moving on, it was like, no, I'm done. Don't leave me. So let's see the Docker images now. And there you see, new container image is the latest version of this particular image. Windows Server Core is there as well. That was created 32 seconds ago. Notice the size is slightly different because we've included some slightly more stuff in there. So we'll create a new container from there. So we'll run docker run, new container image. And there we go, we're inside the new container. So in theory, I should be able to do, if I go to C drive, cd/, there we go, you should see my ipconfig.txt file, and then we can, there we go, and there it is, what we saved before. So let's exit out of there again, and we'll just clean up. And we'll remove everything. Move it one at a time. So remove the container, yep, that's fine. And remove the image, so docker RMI removes the image. There we go. And then we can go through and build the same web server we saw before. So firstly, we'll make a directory. There we go. So we're going to do this on this machine. We'll do the same as we saw before and pull down those bits. There we go. We'll expand the archive. So I'm doing exactly the same steps, at least to get the Nginx bits down. But I'm storing them in a slightly different way because I'm going to create the web server image using what's called a Docker file. And a Docker file contains what we need and what the Docker engine uses, the Docker engine being the piece of the Docker component that's within the container host OS to build and modify a container. So I'm going to go new item. I'm going to create the Docker file. And it's going to create it in the Nginx folder, just for convenience here. So there we go. We've built the Docker file. We're going to open it and see what's in there. And at the moment, it will be completely empty. But a Docker file, I suppose it's not dissimilar from almost a bit like DSC, I guess, where you're telling it, okay,
it's declarative.
Yeah, when you want to do something, do this. So and I'm going to copy this into the Docker file. So you'll see here, there we go. So what it's going to do is going to say, okay, take from the base image, Windows Server Core, call it this, call the vendor this, call the version that, add the source, the Nginx folder that's local to this Docker file. Otherwise, we'd have to specify a little bit more of a explicit path. But there we go. So we save the Docker file. So we'll build now a web server using the Docker file in that location. Do you see how it's subtly different? We're not necessarily spinning up the container first to then download the bits into the container.
We're pre-building the container.
Essentially, yeah. So there you go. Step 1, take the image. Step 0, take the image. Step 1, deploy the bits inside and add those source Nginx files that we downloaded onto the container host. So now what we should see, there we go, successfully built. So if we look at Docker images, boom, there's our Nginx Windows, latest, 8 seconds ago created. It's slightly bigger, just contains those Nginx bits. So now I have to do my firewall rule here. I'm going to edit that again, just to make sure that it works. This is, remember, on the host to allow our to get through to port 80, because we've not deployed the container yet.
No.
All we've done is we've just created the image. We've now opened the firewall, and look at the difference here. So now I'm going to create the new container from that image, but as part of that command, I'm actually going to specify. So I'm creating a new container, running it in interactive mode. The name is going to be Nginx container. We're doing the port configuration of the container here and now at deployment time, and we're specifying that is the image we're going to use and the command we're going to open up when the image or when the container starts up. So again, I'm just presenting the two sides of the coin here. One was with PowerShell, and now I'm inside the container, and I should be pretty much good to go. Let me just check if it's running. Container jump. Let me come out of the VM. I should have maximized it really, but never mind. I'll maximize it and then minimize it because that's useful. 120.229.98. Are you ready? There we go. So 10.120.229.98. Now, if this doesn't work, I believe it's because I've probably not started the web server.
I was actually thinking that.
So that's what happens when you haven't started the web server. So all we need to do is go to cd/, oops. See what's here. That's what I probably should have done, really. Do you need to start a web server when you want to run a web server? I would almost certainly guarantee it. So there we go. Once that's started up, what you should see. Come on, come on, come on, come on, come on.
I think it's just going to hang there.
No.
Do
what it did last time.
You've got to Nginx start to have it kick back, if I remember from the previous one.
From the previous one. Either way, you get the idea. The web server would start. I don't think you do. I think you just have to do that.
Go back and try the IP. See if it goes through.
Aha!
Not just a pretty face.
Or even. Right, so that's us done on the demo. Now, hopefully that gives you an idea of how we do this with Docker. And I know, obviously, it's a little bit tedious watching somebody else run PowerShell scripts. I apologize for that. Try it yourself. The documentation will flash up a link a little bit later. So let's just take a look now at development with containers and how developers can use containers to deploy their applications. But before we do that, let's just pop out and take a look at the documentation that I've been talking about. So what I'm going to do is I'm going to move my browser over to there, and you'll see it's quite a long link. So I think Danny's going to put up a slightly shorter one for you, hopefully. But if you do want to just go to, no, not that one. That's what I was saying, it's not that one. Nope. It is the, yeah, that's it. Nope. There's no AKA on there. If you go to HTTPS or HTTP msdn.microsoft.com/virtualization, even though it says virtualization, it actually lands you on the containers page. So there we go. That's it. There we go. You hired this guy. We need to sort him out.
Corey did that one.
Yeah, it was Corey. We'd have heard if Corey was typing. So there's msdn.microsoft.com/virtualization, and then it will resolve to this full link. And you'll see the scenarios that I actually took you through were get started with Windows Server containers in a virtual machine. So it spins up that VM, and then you're at a point where you can then do the next step, which would be either quick start Windows Server containers and PowerShell, or Windows Server containers and Docker. They're essentially the 3 demos that I gave you by way of introduction. If you do want to use an existing 2016 image when it's available, you can download that and transform that into a container host if you want. I find the VM one a lot easier, but
exactly, very sort of elaborate processes that end in the dramatic use of a static IP to get to a default web page.
Don't belittle that demonstration. It was
I'm not
powerful.
belittling the demonstration. I'm just saying the result is kind of anticlimactic.
Yeah, it worked. There you go. There's actually some more resources that you may find useful. If you go to channel9.msdn.com/blogs/containers, you'll find we've actually built a containers channel. That face just gets everywhere. I can't get rid of it. So I've uploaded a couple of video recordings of that documentation. So if you just want to sit through it again and look through, and these are from the engineers. So it wasn't me recording them this time. It was Lars and Steve Lasker and Jing, all developing these. And Andy Atkinson's one of the videos as well, delivering these great demo video overviews for containers. And there's actually an interview on there as well, Containers 101, where you've got Taylor Brown from Microsoft, Chad Metcalf from Docker, just talking a bit about the why and the how and what containers are all about and why they matter. So if you do want that refresher, you can obviously check those out on the containers channel. So channel9.msdn.com/blogs/containers. So back to the slides. Development with containers. You'll say, well, we've already done some development. I saw how easy it was to deploy a new web server and start it.
A new static web page.
Yeah,
yes.
a new static web page.
And start it part was fairly important.
But conceptually and how we can start to integrate with our developers, let's put a bit more concrete information around that. So we've got our developers on the left in orange. We've got they're using their machines. You've got your central repository within an enterprise, or it could be obviously using the Docker Hub, but we'll use central repository where you've got some images that you've already created. You think, okay, developers can choose their desired frameworks and pull them locally to their system they're working on from the central repository. So you're essentially saying you've already got an image that's got an application framework in. We used the example of Node.js earlier on. They've pulled that locally to work on it. They spin up a container from that. Obviously, the dependencies that app framework needs are pulled automatically as well. And that's important because if you just pulled that application framework image, all it's got in it that's essentially is Node.js in this example and pointers back to the underlying operating system.
There's no operating system in the container.
No, correct. And there's no operating system in that specific image. There's pointers to the base image that it used to spin up that application framework image. So it pulls those dependencies as well locally. So developers use those languages they're used to. They create and build their applications, no different from what they've done before. They just build their applications and they compile them and assemble them in the same way they've done before in terms of the app itself. But then you create the container image from that end result. So they're developing their application inside the container runtime. They deploy, they package, and then it becomes an image that can be used for other stuff. So now that image is in the central repository. So let's say that is line of business app 1 that obviously relies on app framework, obviously relies on Windows Server. So whenever anybody runs this now on a container host, not only will it pull the application image, but it will pull any relevant dependencies, as we saw earlier, automatically.
They could also develop multiple versions of this application and put them in the image repository.
Exactly.
And then, as you know,
so you've cracked it.
At operations time, they can deploy version 3 of the image, the most current version, middle of the night, discover, oh, there's a bug. We need to roll back to version 2. They don't need to redeploy an app. No. They can just change the image the container's using.
Well, they just shut down one container, restart a new container from image
version 2,
n-1, and off you go. Yeah. Exactly, really straightforward. So when we think about what this benefits, if we think about sharing applications for unit testing, sharing the packages or the container images with other developers, push it to staging for more testing, quality assurance, and then you move it to production. It's a centralized process, but you're just streamlining that so efficiently using these containers. So if you think about DevOps processes and that whole continuous integration and lifecycle and agile development and how you link devs on the left and ops on the right, you think you've got your developers building and testing your applications like we just saw, and they're doing that in their development environments that they're used to, like Visual Studio, like Eclipse, like some of the other development environments they're using. They build and they push their images, those container images, to the central repository, and then operations then automates the deployment, pushes us out to the relevant container hosts within the environment, which could be on physical systems. They could be inside virtual machines. Remember, we've talked about both kind of architectures, if you will, and they'll monitor them. Remember, it's a Windows OS. You can communicate with it on the network. Therefore, you could monitor. And we've not talked, obviously, about monitoring tools for containers and things. That will come later down the line. At this point in time, with this first release of containers in the Technical Preview 3, it's about kicking the tires and getting used to what you can do with it.
Fundamentally understanding what it is, for starters.
Exactly, yeah.
Because that's the big, if you're not coming from a DevOps world or a developer world, you're coming from an IT pro infrastructure world, data center world, it's a bit of, it's a new thing. It's not a virtual machine. Yep. Can't think of it like a virtual machine, so you've got to learn what it is before you can think about, monitoring. Then some of those assumptions we see people making based on the questions they're asking, how do I cluster it? You don't, because it's not something you cluster, and that's part of learning what it is, and some of these things become kind of obvious.
Yep. So once it's deployed, Ops collaborates with developers to provide those apps, those metrics. You may provide a dashboard, if you can imagine a system center operations manager dashboard, which has got views of performance and health and availability and latency and all that kind of stuff, useful metrics that operations can use to understand how their application is performing. And if it's not performing well, if something's broken, if something needs diagnosing, if something needs fixing, they can iterate, update and deploy updated containers back to the repository, and the cycle works like that. And it just streamlines it so much. And don't get me wrong, I'm by no means anywhere near a developer, but I can understand the benefit from an IT perspective of providing that standardized container host environment for developers to quickly deploy their applications.
You're kind of near a developer. I do development. So you're kind of near a developer.
Yeah, right, fair enough, yeah. All right, I'll take that.
A pretty bad one, but...
Well, there you go. No comment. The chat lines will erupt on your development quality. We've seen enough red text. But there you go. So some of the use cases for containers. Hopefully you've got in your mind some of these. You've seen how quickly you can deploy applications that could be stateless. Everything is separated out, so we can very much isolate that perhaps database backend from that container web front end, and you're spinning up new web front ends to meet demand, and then shutting them down very quickly once they've completed. And you've got a load balancer perhaps in front of those web front ends so that it's all integrated, works efficiently. What are some of the use cases? Well, think about the workload characteristics first. Is it a scale-out workload like a web front end? Can it be distributed? Is the state, so you mentioned stateless, is the state separated from the workload? Is it a state-separated workload, i.e. can I separate that stateful information, the database, the stuff that needs to be stored from that web front end that's just processing traffic, if you will? Does it need to be rapidly restarted in the event, or booted in the event you need to scale up or scale back quickly? And those kind of workloads, distributed compute, web workloads, tasks that need to be performed, databases can be certainly grouped into that. Maybe not your databases that you would use for your back-end SharePoint infrastructure or your back-end SQL servers that are powering System Center, but certainly there are database workloads that could be candidates for being placed into containers. But the characteristics of containers, they are very efficient. You saw how quick it was to spin them up, shut them down, destroy them. They're very resource efficient because they're sharing that container host operating system. They can be used in multi-tenant environments, but we'll talk subtly about that shortly, where Windows Server containers and Hyper-V containers differ. Automation is big. They can be automated. You saw how I was doing a lot through everything through PowerShell or through Docker. Incorporate that into your regular PowerShell automation or your DSC scripts that we'll learn about in the next module. And it can be scaled very quickly. You've seen how quick it was to deploy, to scale up. Imagine I deployed 10 of those Nginx web servers. It wouldn't be much longer. It'd be a few seconds for each one.
Now contrast that with deploying a new Nginx virtual machine, booting that operating system much, much, much faster.
Exactly. Now, what do you run as the container host OS? You saw me in the demo. I used the container host OS with Server Core that I pulled from the web. I had it locally, but I pulled it from the web in advance. I could use my own Server Core image and customize that to turn it into a container host on which I then run containers. However, we will in the future provide two options, if you will. So if we look on the slide here, you'll see server core we saw. Great, it's high compatibility. You can start to use traditional applications, therefore, as in the containers. But if you're thinking, well, Nano Server would be actually a really lightweight container host OS, and therefore the containers themselves would be very lightweight in addition. Yes, Nano Server as a container host, as well as the Fabric configuration we talked about in the Nano Server module earlier, that's great. But the same kind of applications you could put onto a server core machine wouldn't necessarily be compatible with those that would run on Nano Server. But you've got the option for both. Obviously, if you want to create a Nano Server-based container, it's going to run on a Nano Server container host OS. There's something to bear in mind there. But they're the two environments. Notice full server isn't there. That's intentional. Nano Server and Server Core are our chosen and recommended two options for the container host OS. Remember, that container host OS can run on physical, it could run on inside a VM. So what are these runtimes? Well, one of the runtimes we've spent an extensive amount of time discussing, Windows Server containers. When we start up, when we run new container or start container, it creates the container from an image, and that is the runtime that is running at that point in time. That is a Windows Server container, and it's what is available in TP3, Technical Preview 3, of Windows Server 2016. However, there is one additional runtime, a different type of container runtime that we will also bring to market. It's just not in Technical Preview 3, and will be introduced in a future Technical Preview. And that is a Hyper-V container. So to compare and contrast these, I've got some slides and graphics that might help illustrate that. And admittedly, the first time you hear about all of this, it's quite bamboozling. There's a lot of information in there, and it's hard enough to grasp Windows Server containers on their own. But what have we seen from a Windows Server container perspective? Well, they share that base OS. They can be highly automated, very scalable and elastic. They can grow very quickly. They're very resource efficient because of that sharing. In a trusted multi-tenant environment, where your applications that are linked together, they trust one another, a more secure environment, Windows Server containers are great. But with Hyper-V containers, it is an alternative type of container that provides extra levels of isolation for specific containerized workloads. So particularly if you've got a regulatory compliancy requirements, or if you're in a shared hosting environment where you're running multiple applications from multiple customers on the same hardware in a public multi-tenancy type environment, Hyper-V containers can provide an extra level of isolation for those key workloads. So what you lose with Hyper-V containers is a slight level of efficiency and scale, because Hyper-V containers they're going to use a little bit more resource, they're going to use a little bit more for that isolation, but what you gain is that level of isolation.
So we think about it this way, Windows Server container, virtual machine, a Hyper-V container sits kind of in the middle.
I would say so, yeah, that's a fair analogy to make. And if we look at the graphic here, you'll see the two runtimes illustrated. The key thing to note here with these two container types is the same underlying image that you use. So let's say I'm a developer, I've created an application that's in the top left here. It relies on Node.js, which in turn relies on the Windows Server base image. At runtime, when I say I need to deploy this container, I choose, do I want to deploy this as a Windows Server container? Go. Or do I want to deploy this as a Hyper-V container? Go. Regardless of which one I choose, it still uses the underlying images from the left. It still it pulls them across to the local repository as and when it needs them and runs them. So
yeah, as a developer, you can build a container image. You don't necessarily need to think about how it's getting deployed, whether it's Windows Server or Hyper-V. And the operations team that's deploying this can look at it and go, you know what? This is going in an untrusted environment where I don't necessarily have all the applications trust each other. Hyper-V container. This is all internal apps, fully trusted. Windows Server container. Better density, but less isolation versus lower density, more isolation.
Yeah.
So it becomes an operational deployment time decision versus a design or development decision.
Yeah. And the nice thing about these container types is that the management that we've got for Windows Server containers and Hyper-V containers is the same. Obviously, there will be subtle differences in terms of you'll say new Hyper-V container or whatever the commandlet may be. That will obviously say, yes, okay, now we'll deploy a Hyper-V container versus a regular Windows Server container. But from a Docker perspective, Docker will also manage, control, deploy, package the Windows Server containers and the Hyper-V containers as well. So again, it's unified the management. Developers, it won't make a difference. They'll still be building their app in the same way. Deployment time, you make that decision. So to help explain this, and I realize this is quite a complex concept to understand now, we're just getting your head around the regular containers, Windows Server containers, and now you're throwing in this curveball of Hyper-V containers. And you're trying to get us to separate virtual machines from containers, even though you're now including the word Hyper-V, or word plus extra letter. Let's go into this graphically and hopefully try and illustrate this a little bit more. So we've got our regular physical host or host operating, whatever that black box is there.
It really does look like my AV receiver.
That is your physical, let's call it a physical server for argument's sake, physical piece of hardware, onto which you've installed, let's say, Windows Server 2016, Server Core, and enabled the containers functionality. So that has now become your containers host. On there, you have then created some Windows Server containers, just like we did in the demonstration. Okay, so everyone should be with me up to that point. We've not done anything different that we didn't cover before. So there are your Windows Server containers. That little blue line is just to illustrate, yes, there's container OS virtualization stuff happening, not Hyper-V. The alternative to that is saying, okay, you've got your physical system, you've enabled Hyper-V, and your parent partition is now running as a privileged parent partition, onto which you've enabled the containers bits in the parent partition, and you've created some containers from the base. So they're still Windows Server containers. But in addition on there, you can create virtual machines, regular VMs like you would today with Hyper-V, but there's a little gap in the middle where we could also create these more isolated Hyper-V containers. So we're using our knowledge, our experience, our Hyper-V expertise to create these more specific, I don't want to use the word secure, but these more isolated Hyper-V based containers that are using that virtualization technology to isolate the containers from one another in a more effective way. Now, what that means is we've got these two different types can run in harmony on the same system, no problem there, but one is a Hyper-V container, one is a Windows Server container. And just to make it even more confusing...
wait, am I seeing what I think I'm seeing?
You're seeing what you think you're seeing and probably what you want to see as well, but I will clarify. So I've gone back to the slide there, so bear this in mind. Windows Server containers running on a regular OS, Hyper-V containers running on the... So Hyper-V containers, there is a big prerequisite to creating a Hyper-V container. You need to have Hyper-V present. And you think, okay, well, traditionally, I can only enable and run Hyper-V on a physical system. Correct? Are you with me?
I'm with you.
So I've got a physical server, I enable Hyper-V, I can create Hyper-V virtual machines. What I'm showing you on the graphic there is, okay, you're saying you can run Hyper-V containers. Yes, you can. They need the Hyper-V hypervisor to be present to do that. Okay. So what if I want to run containers inside virtual machines like you did in the demo? You had a Windows Server Core VM, and that was your host, container host OS, and you ran containers inside there. How would I do that with a Hyper-V container? Well, this is where we will support essentially nesting. So Hyper-V hypervisor will be able to be enabled inside a Hyper-V virtual machine. So let's work it up from the base. You've got a physical system, you've enabled Hyper-V, you've created a VM, Hyper-V is enabled inside that VM, and inside there you are creating a Hyper-V container. Contrast that with the one on the right where you've just got a VM and a regular Windows Server container. That's more analogous with the demo we did earlier where we had the virtual machine was running Windows Server Core as the base, and then you created a regular Windows Server container inside that.
Now, at which point are you going to modify the space-time continuum in this? Because you're getting pretty close.
I'm bending physics right now. That's possible. But again, it's the Hyper-V and the containers team. It wasn't me. I'm just sharing the love. There's a lot of container love to go around. Now, that is going to blow your mind.
You can hardly contain yourself.
I can't contain myself. It's too much. That's about the only pun we can do with containers, I think.
There's a few more. Trust me.
All right, I'll leave you to ponder those. The key takeaway here is Hyper-V containers can be run on the physical system because they need Hyper-V, or they can be run in a VM. But again, they need Hyper-V, so we enable the Hyper-V role functionality inside the virtual machine. So yes, that does essentially enable nesting virtualization because you've got a virtual machine running with a Hyper-V role enabled. And remember, a container, when you spin it up, it's just an operating system. So in essence, that OS is going to think it's got Hyper-V.
Perfect.
So that's some of the subtle differences. If we think about the tools, it's the right tools for you on the right platform with the right development environment from the ground up. Whether you want to deploy your containers onto Azure, on-prem, with a service provider. You've seen we abstract it away, we deploy, it's flexible. Whether it's Windows Server or Linux, you've got the flexibility through the management tools, especially tools like Docker, to be able to manage both in a uniform way. Whether that's Windows Server containers, Hyper-V containers. In terms of developers, reassure your developers they don't have to do anything differently from building their applications. They can, obviously they can. There are ways to build applications that split them across multiple containers, so it may be a change for them, but actually the building of the app shouldn't change drastically. So we can include development environments like Visual Studio, which has awareness of containers and will obviously integrate with things like Docker as well. We recently published a Docker integration resources kit as well for Visual Studio. Other development environments like Eclipse and so on. And we utilize platforms like the Service Fabric that will come to Windows Server in the not too distant future to enable a platform to run these containers very efficiently in a very streamlined.
I want to be part of the conversation that goes, I'm running it in the container on the Hyper-V VM, in the container on the VM, in the container on the host.
I don't want to be part of that conversation. It's quite confusing.
There was a movie kind of like that, I think, not too long ago.
Potentially, yes. Now that brings us to the end of this particular module. Now, before we go on, I've been a little bit harsh on Corey, and we've
a little bit harsh.
We've been going back and forth about his demos and all that for the last 2 days, and I want to say I've got a gift for you. So let me just get down off my box. Let me get. I've got this.
It's a container.
Yes. So, yeah, but there's something in there.
There is. It's not very secure.
Open it for everyone.
There's not very secure because I can see right through this container.
Well, yes. All right.
So the
what's that?
It's a package.
It's as close to a package as I could get. The mailroom didn't have
was this a Docker package or no?
This is just a package.
So this says, let me see here, Windows Server 2016's TP3 is available now.
Available now. So Danny, if you can flick up the eval link, there you go, WS 2016, eval WS 2016. So aka.ms/eval WS 2016, and you should be able to download the bits that contain the container bits as well, so you're able to utilize everything we've talked about over the last day or two.
I'm going to store this in the repository.
Yeah, do it.
And
you haven't made any changes?
I have not made any changes.
It's still the base
still
image.
A base container.
Right.
Put it on the Hyper-V.
It's a Windows Server container.
Exactly.
It's all right. So you can download the bits now. You can grab them. Obviously not now. We've still got one more module, about half an hour to go. But yeah, you can start to get started with containers, with the software-defined storage stuff we talked about yesterday, the networking, the virtualization features, all of that cool stuff. I apologize for the very cheesy way that we
did not rehearse
announced.
that.
And even though all the chat people are like, yeah, we already know.
Yeah, I know.
It's been out since this morning. I know.
They stole his thunder.
I know, it's so harsh. So that brings us to the end of this containers module. Hopefully you found that useful. We covered a lot of ground: Windows Server containers, Hyper-V containers, why you'd use them, how they differ from virtual machines. Good demos, I hope.
Yeah, fantastic demos.
Thank you.
Definitely, a concept you've got to wrap your head around if you see it for the first time. So.
Exactly. So hopefully, if you watch it a couple of times or you read the documentation and try it out for yourself, you'll certainly grasp containers more and more as we go forward. And remember, you can try out Windows Server containers in Technical Preview 3 today. And that brings us to the end of the module. So please join us in the next module where we're going to be focusing on automation.
We'll see you then.
See you then.